So today we're going to go over a little bit more with equations of lines that are parallel and equations of lines that are perpendicular. So to find the shortest distance between two parallel lines is to actually find a line that's perpendicular to both of those lines and find the distance between those intersection points. So that's what we're going to do. So in example 1, we want to find the distance between parallel lines L and M with equations y equals 2x plus 1 and y equals 2x minus 3 respectively. What does respectively mean? Do you know? So when it says line L and line M, line L would be this first one because L was stated first. M would be this second one because it's stated second. Okay, that's what respectively means in any logic. And you do get problems like that on the ACT where it'll tell you respectively, so just so you're aware of what that means. So my first step here is, for finding the distance between these two lines, is to actually graph the lines so I can see where they are. So we're going to graph line L, which is this one right here. So we have our y-intercept for that line. So I can plot my y-intercept at 1. Okay. Then I'm given a slope of 2. So slope again is rise over run. So I would go up 2 and right 1. Okay. From that point I can also go up 2 and right 1 and so on and so forth. Okay, so this would be line L. Oh, mine got a little crooked there. And then we also want to sketch line M. So again, using the y-intercept. Okay, y-intercept is -3. And since these are parallel lines, your slope should be the same. So we do want to go up 2 and right 1 for each of those next points. Or down 2, left 1 will also work. And I know my first line was crooked, so make that one a little bit better. Okay, so here's line L and line M. We next want to find an equation of line P. Okay, line P is going to be your perpendicular line that intersects both of those. So finding the equation of line P, we want to use the y-intercept from one of the lines and the slope of the line that would be perpendicular. Okay, so the y-intercept I'm going to use this 1 here instead of -3. So my y-intercept will be 0, 1. And I want to state which line I took that from. Okay, so 1 is the y-intercept of line L. Okay, so that's from line L. So using that information, I want to write an equation of a line that is perpendicular. So that means I need a slope that's perpendicular to the one I just used. Do you remember how to find a perpendicular slope? Given this one right here. What would be the perpendicular slope to 2?
-1/2x.
Is -1/2. You have to take the opposite sign. Okay, so it was positive, now it's negative. And then the reciprocal. So flip 2 to the denominator to make it 1/2. So writing an equation of a line perpendicular, we are going to use this y-intercept. So I would have y is equal to -1/2 x. And I want to use that same y-intercept of 1. Okay, so if I were to draw this in, I would have a y-intercept of 1, and my slope is -1/2. So I would go down 1 and right 2 to plot that next point. Okay, down 1, right 2. Okay, so this line right here is your line perpendicular to L and M. Now you can use line M for your y-intercept, so you can have a y-intercept of -3 instead if you want. You're still going to get that same distance. Okay, it's up to you which one you choose. So now what I want to do, I know my intersection point of, this is line P and line L because they have the same y-intercept. I need to find this intersection point of P and M. I need to find the intersection point of P and M. To do that, you need to solve a system of equations. Okay, you did this last year in algebra. You have to solve a system of equations. So in number 3, we want to list the equation of line P. Okay, so that's the one we came up with right here. So y equals -1/2 x plus 1. And the equation not used in number 2. That's why I had you write out which line I took this from. Okay, so I used line L for number 2. So the one not used would be line M. And line M's equation is y equals 2x minus 3. And we are trying to find these points of intersection. So where they equal that same point. So to solve this system, since they're both in the form y equals, right, I can substitute this equation in for y over here, right? I can just set those two equal because they're both equal to y. You see how I'm getting that? Yes? Okay, so I can set 2x minus 3 equal to -1/2 x plus 1 since they're both equal to y. From here, I just then want to solve for x. Okay, so if I add 1/2 x to both sides, I need a common denominator for that 2. Well, it'd be 2.5, right? But if I get a common denominator here, I would have 4/2 x plus 1/2 x. Right? So then 4 and 1 together is 5/2 x minus 3 equals 1. Then I can add 3. And yes, I'm going to keep it as a fraction. Now if I have 5/2 x equal to 4, do you know how to get x by itself? Multiply by the reciprocal. Yeah. So I'm going to multiply by 2/5 on both sides of that equation so that these fractions here cancel. And you're left with just x. Okay, so x will be equal to 8/5. Now, since I'm solving a system, you have to find out what y is equal to as well. Okay, I found x. I also have to find out what y is equal to. To do that, I need to plug in what I got for x into one of my equations here. Doesn't matter which one, just either of them. So I think I'm going to use this one right here. Okay, so to find y, we would have 2 times our x value of 8/5. And then minus 3. Okay, 2 times 8/5 is 16/5. And since 3 is just 3/1, again, I need a common denominator. So my common denominator would be 5. So I need to multiply both 3 and 1 by 5. So I have 16/5 minus 15/5 to get y is equal to 1/5. Okay, so my intersection point of line M and line P would be at 8/5, 1/5. Okay, remember all of this process is to find the distance between two parallel lines. Okay, whole process is to find the distance between those parallel lines. So the last step here is to actually find the distance then. So we want to find the distance between the y-intercept from number 2. So if you look back up at the top in number 2, the y-intercept we used was 0, 1 from line L. And the intersection point, okay, is the one we just found, that's Q. So that would be 8/5 and 1/5. We want to find the distance between those 2 points because they are on both line L and line M with that perpendicular line. So to do that, we just use the distance formula. So again, using distance formula, you can label your points x sub 1, y sub 1, x sub 2, y sub 2. Okay, and then we just have to plug it into our formula here. So x sub 2 is 8/5 minus 0 squared plus y sub 2 is 1/5 minus 1 squared. Okay, and you can just enter that into your calculator right away. Don't have to worry about getting common denominators. Your calculator will do that whole thing for you if you enter it correctly. So I do want you to try that. If you have a calculator, try and enter that into your calculator before I give you the answer. Should be 1.8. Okay, so make sure you add enough parentheses around it. So you do need parentheses around your fraction before you square it. Let me see if I... So even more parentheses is always better. So if you do your square root, I would do another parenthesis and then 8 divided by 5. So you have that fraction. Okay, if I subtract 0, it's just going to be squared. So that quantity is squared. Okay, plus I'm going to have this whole quantity, right? But I also want a quantity around my 1/5. So I'm going to add in another parenthesis here for my 1/5 so that I can subtract 1 from that 1/5 and that whole quantity so that I can square it. And then if I end the whole thing here, I do get 1.78. But you need to add those parentheses around your fraction. Okay, you have to add those parentheses around your fraction if you have a fraction in your answer here like this. And I can help you with your calculator if you need help with that as well. Okay, questions on what I just did? I know the process is kind of long, but I do lay it out for you step by step of what you should be doing. Okay, so Graph the line. Find the equation of the line perpendicular using one of the y-intercepts. Then solve the system using your perpendicular line in the other equation, and then you can use the distance formula. Okay, questions? All right, I want you to try the one on the back of your note sheet. Okay, that one does have larger fractions as well, I'm sorry. The ones on your assignment do not have fractions like this.
Every way I do it, I get 2.2.
I mean, you really have to think about what you're doing. This first parenthesis is for the whole entire square root, so I usually ignore that. I start typing.
Oh,
And then you would enter your parentheses according to this.
okay.
It doesn't matter. Whichever one you prefer. No, this is just
Oh.
So you have to subtract one first on both sides, right? And then, so then you have to do the common denominator thing. So it's,
yes. Don't subtract one and multiply.
Oh, yeah. So then over here.
Yeah.
Here.
It's gonna be
Was it like that?
I need a trust ring.
I just need to get the final answer because I don't know the calculator.
No. You got this point right though? Okay. What did I do wrong? Oh, I put 1 instead of 5.
Come on.
Wait, can I have a worksheet?
I should do this one opposite.
Yeah, just wait.
You get that?
You're Justin.
It depends which one you have as a y-intercept.
Oh.
If you have a different y-intercept for your starting one, you're gonna have different intersection points. For which one, I don't know.
Minus 9.
the 33 over 10 one.
Got it.
33 over 10 is positive.
Alright. I'm just gonna cross out the negative. I'm I got negative 149. Negative 1. Yeah, I don't know how though. Huh? 'Cause I got. Yours sounds more accurate. I don't know why. Maybe I
Which one did you use as a?
honestly.
I don't think I'm.
That's okay. It is. That's great. Yeah.
Yeah, that's it.
We're at the. John.
I put the
I
answer.
got 475.05 for.
Oh, I don't know. I have to do it using M because I did it now.
Should I just call it? That's what it is.
Should I just call it? That's what it is. No.
How many problems are on the board?
Just two.
Okay, bad.
There's no homework.
No, there is.
Never mind, I was just gonna ask a question like when I found out that once when you swap this, you multiply by 11. Okay, thank you.
All right, so I do want to show you both answers here. Either way you do it, you're going to get the same answer for the distance. So I just had to redo M because some of you did use line M instead of line L. I used line L on my original one. So if you used M, okay, if you used M, your equation perpendicular would be plus 6 because that's your y-intercept for M. Okay, then for my intersection point, I did get negative 33 tenths and negative 49 tenths. Okay, so when you solve that system,
I got negative 139. You did a different one. I know, but it's still bad.
did you keep it as negative 99 tenths?
I just plugged in negative 3 and then in parentheses negative 32 and then minus 5. And it gave me the number. I had negative 39.
You used line L. Use L. I'll show you that one. Okay, so here just solving, I have negative times a negative is a positive 99 tenths minus 5. I need a common denominator here. So multiplied by 10 for both. Then 99 minus 50. This should be positive. I don't know why I wrote negative. Because I'm crazy. So that should be a positive 49 tenths. The last one I didn't write out, you're going to get the same answer anyways as line L. So if you use line L as your y-intercept for negative 5, here's your equation of the line perpendicular. Okay, solving your system, you get x is 33 tenths and y is negative 39 tenths. Okay, so there's your coordinate point. Okay, for both of them, your distance should have been 3.5.
Oh, yeah.
Okay, both of them, your distance should have been 3.5. With your assignment, it does look exactly like what you just did. You do not have any fractions as your answer. Okay, you do not have any fractions as your answer. Now, when you're solving the system, you might get some fractions, but at the end, you shouldn't have any as that intersection point.
If 264 divided by 36 divisible by 36.
But you follow those same exact steps we just did.